Well, really great to be here. Mike, thank you so much for the wonderful introduction. I have to say that, sorry I sound like an adolescent whose voice is cracking, but I was doing too much work at the karaoke bar yesterday, and so the things I really do for Siemens, I have to say. So anyway, first let me just say this. Thanks for the opportunity to share the Siemens perspective on PROFINET this morning. Over the course of the session, we're going to have the chance to hear from many different perspectives and have a much deeper discussion on this technology called PROFINET. For me, I would just say that I always like to sum this up in a Twitter kind of statement. And my Twitter statement would be simply this, that PROFINET has been and will be the enabling force for bold new advances in automation and our adoption of the Internet of Things. And we already see that playing out very dramatically in industry today. So we've seen a surge of growth in PROFINET. Now about 7.5 million nodes. What's fascinating to me is that the number of nodes has almost quadrupled between the end of 2008 and today. Okay, here we go. Good. And so, for industry, what we see is we see a lot of broad tectonic shifts that are happening, such as reshoring, shale gas. These are all having an impact on the way factories and plants operate every day. Three imperatives really stand out that I want to talk about, and those are really very, very clear, more clear than ever before. I would say efficiency, performance, and flexibility. I think you'll hear through the course of these conversations how PROFINET's playing a very substantial role in each of these three areas. So first, companies need to increase their efficiency in their use of energy and resources, which also includes adapting to unconventional sources of energy. Companies also need to improve their performance and shorten their time to market by merging the worlds of real and virtual production. We heard a lot about software today and the role of virtualization in virtual production, as well as linking the worlds of automation and drive and MES systems together. So finally, companies also need to enhance their flexibility, cope with shifting demand trends, mass customization, the era of big data, product variants, and also a lot of changing regulations. And when you look at PROFINET, it really addresses exactly these three imperatives that we're talking about, and we'll get more into the details of this. So, if again, you look at these three strategic imperatives, here's a snapshot of the benefits that we talk about. I don't want to read through all the individual benefits, but these are the benefits we talk about with our customers and what they want to know and how PROFINET can help them address some of their challenges. And while, again, I don't want to go through all these in specific detail, I will say that taken together as an integrated whole, PROFINET really helps our users implement the most innovative machine and plant concepts possible today. It also offers the freedom to structure their machine and plant architectures in a way that make the most sense for their business. And as a result, what we see here again is PROFINET offers our customers a very sustained benefit in terms of this energy efficiency and performance flexibility. So PROFINET and this ecosystem of applications that are growing up around it are bringing a much, much higher intelligence to the world of automation. Think of where we've been until recently. The automation world of yesterday was primarily about local technology. And there were clear boundaries drawn about the system, and any development had to happen very much within those boundaries. Today, we are really communicating in a communications-based world of automation. Sensors and communications are making decisions. Decisions are being made autonomously. Software is connecting factories so that there's a seamless interplay of communication back and forth. The geographical boundaries that we saw traditionally and in the past have really disappeared. So in the future, what we see is that the entire product and production process, from product design through production design, is going to be optimized and increasingly simultaneous, not serial. So that means synchronizing the processes from the initial product idea all the way to product delivery and services. And we see, again, very excellent examples. The auto industry is an early adopter of these types of technologies. Aerospace industry is following suit, but you've heard so many examples of the first commercial spacecraft, the Mars rover, right? And the list goes on and on. Golf clubs, all being virtualized before they're built. And so this requires a very, very capable backbone to move this data around. So what I would say at each stage of the process, from planning to developing to building to supporting, processes are really merging. Time is shrinking. Life cycles are getting unified. And I would say this holds true now for both the product life cycle and the production life cycle as well. So, tomorrow what we see is really concurrent processes, very synchronized between product and production. And, again, what this shows is we're bringing really the world of design and virtual production together, combining them with the world of real production. So in terms of our Siemens technology roadmap, integrating these worlds is the guiding principle behind our industrial product portfolio for hardware and software solutions, and we're innovating on both sides. And, we take this holistic approach because 80% of all of our production costs are predetermined, and 80% of production costs, just by the best studies, McKinsey has stated it, but really in practical manufacturing, you hear this from many companies, our production costs are largely predetermined in the product design phase. And this is based, again, on research done by McKinsey, practical knowledge and application. But what I would say here, again, is the worlds of virtual and real production are tightly linked and very mutually dependent. So, if you're looking to control production costs after you've started, or design costs after you've started production, you may be missing some very valuable opportunities to increase efficiency. And what I would say here, again, also, is a key focus for us to deliver these very comprehensive solutions to our customers. That's why we're investing to build or acquire the best technology to fill our solution set. And in each of these areas that you see here on the slide, we are working at best-in-class solutions that are designed to work together. And this is where a lot of the innovation and technology goes. It's defining the meat points of all these areas and bringing this together. Because, this as an integrated whole is able to shorten time to market. For many, many customers, we've seen reduce time to market by up to 80% for certain products. And also reduce the cost in engineering time. So, one absolute imperative is, the engineering cost per labor hour is going up. So, the key is how do we reduce the overall cost of a system, and how do we use tools and innovative technologies to do that? And, really a great example here is one of our most important innovations in Siemens, the TIA portal. So with this particular portal, PROFINET is the communication standard for all the new products. For our new S7, for the S7 1500, it's the core, it's the backbone of totally integrated automation. And with this TIA portal, we're offering a fully integrated automation engineering environment for all the engineering tasks. And this is, again, fully tied and based on the PROFINET open standard. So this for us includes controllers, HMIs, networking topology. Again, what were separate and separate systems in the past have been merged into one engineering framework. Motors, drives, motion control, CNC. And so with this portal, the engineering workflow is supported. The engineering workflow becomes very intuitive. And it goes back again to the point I made about reducing the engineering cost of implementing a system. And this is where we see the reduction in engineering time by up to 30%. So, and the portal is not necessarily a new product. It's a new framework. We've released the first version in 2010, and that was after Siemens spent more than 5 years of development on this. So we expect that this, in that 5 years of development, will give us, a 15-year competitive edge in the future. And here we've invested over $1 billion in research and development, true research and development, designing this product, worked through usability testing on 5 continents. And so this is the type, again, of cutting-edge innovation that U.S. manufacturing needs today to deliver new innovative products at the maximum level of productivity. They simply have to get more out of their plant assets. And that's what this technology enables companies to do. Okay, so let me just segue now into the automotive industry, because we have a very esteemed speaker, Mike, that's going to talk very specifically about this industry. And I talked about the automotive industry being an early adopter in setting the manufacturing pace for many, many other industries here. So when you take the automotive industry, the United States is really emerging as a global bright spot for automotive sales. Pent-up demand, easier credit, highest consumer confidence in 3 years. It's really driving growth. Vehicle sales reached a 5-year high in 2013. And a few weeks ago, we also here had the privilege of demonstrating our technology as part of Ford Motor Company's major unveiling of the new F-150 truck. And the image you see behind me here is not the plant floor, but one of the actual assembly lines that Ford, Siemens, and Kamau set up on the exhibition floor. So in one of the largest consumer shows in the world for automobiles, we had a fully functioning assembly line at this show. And a highlight of that demonstration was the PROFINET-enabled technologies. And a great example is safety. So here, PROFINET solutions deliver a new level of interoperability of the different components because of the open standards approach. And this gives the flexibility to tailor solutions to fit very, very specific requirements. We were monitoring energy consumption in this line. We can put the line in a low power mode. In essence, putting this line in essence in sleep mode, just like you'd put a computer in sleep mode. So you save energy during non-peak usage periods. And plant safety, let's say, just can be dramatically improved because the components are constantly communicating with other devices, such as safety PLCs, sensors, warning devices, and also alarms. And let me just say that, in closing, I'd like to say that we're very committed to this concept of an open standard, and as a member of Profi International, a longtime contributor to both Profibus and Profinet standards in terms of driving adoption, we're also making it very easy for customers to migrate from Profibus to Profinet when the time is right. So here we offered a staged approach that users can start with small plant sections rather than converting an entire plant. We've taken great care in the migration from Profibus to Profinet. So it's easy and it's as smooth as possible. But, I want to get off my soapbox now and hand it over to Mike to really add the details behind how this works and its practical deployment at Ford Powertrain. So Mike, I'd like you to join me on stage. Thanks.